Good morning. Today is Thursday, January 7th, 2021. We're with our probability unit again for Chapter 3/Topic 3, Expected Value. Now, expected value involves the likelihood of a gain or loss in a situation that involves chance, which we know as probability. It can be a financial gain or a financial loss. There is a formula for it, though, where it goes like this. EV equals probability of winning times your gain. When you get that answer, you subtract it from your probability of what you're going to lose times how much you actually have lost. What your loss will be. You'll see it as I do actual questions today, how this formula works, and how you take apart the question because it will give you information that will fit into these categories. So, before I forget, the objectives of this chapter are complete an expected value chart, calculate the expected value of a simple game, solve problems involving expected value, and make decisions based on expected value. Now, even though expected value probability example 1 is finished, let's walk through this question. A game has 5 cards, one of which is the winner. The game costs $1 to play. If you select the correct card, you win $4. Can you expect to make money if you play this game a few times? So, A says, what's the probability of winning then? What we look at is to say, okay, it costs us $1 to play, and the game has 5 cards. The probability of winning, though, is if you select the correct card, you win $4. Well, let's talk about what the probability of winning will be. You have 1 card out of 5 that's going to possibly be a winner. There you have your probability. That's as a fraction. As a decimal, it can be 0.20. As a percent, you have a 20% chance to win with the way that it's set up to play. B, the amount of gain. The amount of gain if you win is, well, if you win, you're going to get $4, but don't forget, it costs you $1 to play. So you actually are going to gain not $4, you're actually going to gain $3 as your winnings. C, the probability of losing. Well, 1 out of 5 cards will have you winning. 4 out of 5 cards basically are going to go against you and have you losing. As a decimal, that's 0.80. As a percent, that means it's an 80% chance you're not going to win. But people still play those kind of games of chance. And if you lose, well, how much does it cost to play again? If you remember looking at the question, it costs you $1. So if you lose, you're out $1. So now let's take a look at that formula that I didn't get rid of at the bottom here. I erased the stuff from the definition of expected value, but I kept the formula. So the probability of winning. Well, the probability of winning is going to be basically 0.20, which is your 20%. We'll keep it as a decimal. If we do win, we're going to win $3. Now the probability of losing or loss, if we do have a probability loss, is going to be 80%, which is 0.80, keeping it as a decimal. Then if we have a loss, we're going to be out $1. So what we need to do is do some multiplication with this guy here first, 0.20 times 3. We'll get our answer from that, which will give us 0.60. Then we'll go, okay, 0.80 times 1. Well, it's going to give us 0.80. Second step in that, 0.60, take away 0.80. You have a negative value it's going to give you on your calculator. If you actually try it, you're going to get negative 0.20. So what does that mean? Well, the question says at the bottom, that means that every time you play the game, you can expect to lose 20 cents. If you play this game 10 times, you will be expected to lose $2. I'm going to erase that example 1, keeping the formula there, erase the other parts to it, and we'll get to example number 2 of expected value, expected probability soon. Example 2 of expected probability, expected value. Here is the question. Based on past experience, a building contractor estimates the probability of winning a contract is 0.30, which is what I've written here as PW equals 0.30. He's got a 30% probability of winning a contract that he bids for. He has a 0.70 or 70% probability of loss of not getting the contract, which I've written on the board as well. Now, the amount of gain, well, the thing is, if the person wins the contract's worth $25,000, so they have a chance at $25,000, but here's the catch. They have to put a bid in, and to do that, it costs them $2,400. So what occurs is that they will put a bid in, and they will make, after they take away the cost of their bid, $22,600. That's their gain after they remove the cost for the bid. Now, if they don't get a chance at the contract and they've still submitted a proposal, it will have cost them $2,400 to do that. They will be out of a loss of $2,400 if their bid isn't successful. So, what do we do now? Well, we have everything we need. The probability of winning is 0.30. We know that to be a 30% chance. If they did win, they're going to get $22,600. We're going to multiply those soon. Probability of a loss, well, that's going to be, well, for probability of losing, is going to be 0.70. The loss that they'll take and incur will be $2,400. We're going to multiply those soon. So what we do is we get our calculator and we go, okay, well, we got 0.30 times 22,600. Now on my key, I didn't show that step, but I'm going to show it on the board. We're going to take our calculator and go 0.30 times 22,600. 6,780. Now before I do some subtraction, I have to do the multiplication math on this side. So 0.70 times 2,400. 1,680. Now we're going to do some math here now. 6,780 subtract 1,680, $5,100. Now what does this mean? Well, it means that any expected value that's over a positive value means that you have a pretty good chance that it's worth doing. If you have an EV, or expected value, that's 0 or below, it's highly recommended that if you calculate out your EVs and get a 0 or anything in a negative value, that you don't attempt it. You're going to lose a lot. And it's not meant for you to actually win, especially in a card game or a game of chance. In this case, an expected value of $5,100, that means that this person should bid on the contract. They should go for it and attempt the contract. And it asks you, what are some of the other factors to consider before taking the contract if the expected value is in this person's favor? Well, some of the things to remind yourself. Can they succeed in fulfilling the contract? Do they have enough staff? Do they have enough time? What's the reputation of the company that's offering the contract? What's the reputation of the company that's wanting you to bid for it? Will they pay you? A lot of questions to think about when you think about expected value and your probability of loss and gains. Example 3 of expected probability off of your Chapter 3, Topic 3 assignment. Or not so much assignment, but your notes. So, let's look at it. A farmer is deciding whether it is worthwhile to grow a mixed grain crop in one of his fields. He knows from experience that he will be able to harvest a crop 8 years out of 10. Seeding, fertilizing, and harvesting, that's going to cost him $200 per acre. He estimates revenue from a good harvest to be $350 per acre. Should he continue growing crops in this field? How much money will he make or lose if he's farming a 160-acre field. So the first thing that we think about is the probability of winning. He's able to harvest a crop 8 out of 10 years. So basically, that's your probability of winning, 8 out of 10. He's got an 80% chance, 0.80. His probability of loss, though, is going to be, well, he's got 2 years that things aren't going to work in his favor. So it's going to be 2 out of 10. He's got a 0.20 or 20% chance of things not being successful for his fields and his crops. Now the gain, if it's a good year, it's $350 that he'll gain from an acre. But it costs him to seed and fertilize $200 an acre, $200 an acre. So we take the $350 that he can financially achieve, subtract the amount he has to invest, and he's actually coming out with a gain of $150. But if he's put all the work into his field and things don't work out and the field doesn't produce, he's at a loss of $200 for the fertilizer and the seeding and the harvesting that wasn't successful. So now we have pieces to our formula. The probability of winning is 0.80. The gain is going to be $150. Eventually we're going to do the math to that and subtract it from the probability of what you're going to lose. Well, it's a 20% chance, or 0.20, and that's going to get multiplied to your loss of $200. So what we're going to do there, again, I'm going to do the calculations with you. 0.80 times 150. 0.80 times 150. 120. 0.20 times 200. So now I've got 120, subtract 40. EV equals 80. An expected value of $80. What does that mean? Well, again, earlier I said that if it's an EV 0 or better, it's worth doing. The way over 0, higher you are over 0, that's even better for you. If you're 0 or negatives, don't do it. So now the other question part says, well, what do we do now if he has a 160-acre field and basically his EV value is $80 per acre? Here's what you do. You take your 160 acres times your $80 per acre, and what he will get, he will make $12,800 for his, well, he won't lose, he'll actually make money. He'll make $12,800 for his 160-acre field. It's worth it for him to do. It is worth it for him to attempt. Having a small percentage of loss of 20% or 0.20, it is definitely worth it. You can see it as you build the question. That is the expected value probability example number 3 from your notes. Before I let you go, with the expected value probability topic 3 lesson practice questions, lesson 3, the first question has you using a probability expected value chart. What I recommend doing is doing like I did in this other example question 3, where I actually put the things down into different pieces, and then you can put them into your chart. Consider the following game. You have a 1 in 5 chance of winning the game and a 4 in 5 chance of losing. The game costs $1 each time you play. If you win the game, you receive $4. This is very similar to one of your questions in your example set of notes that we talked about minutes earlier. The only thing I don't like about it is I had to show you what an expected value chart looks like. That's part of the curriculum. But what you might want to do is just use the expected value formula, break things into pieces like I did here. Look at your example from your notes and put them back into the different sections here. If it still doesn't look good to you, move on to the next question. The next question is a contract question, very similar to what you did in your notes. Look for the different pieces you need, find out what your gain is, find out what your loss is, so on and so forth. Number 3, the bird bath one. Read the information carefully. Look for what amount of bird baths out of 100 are defective, what amount of bird baths out of 100 are good. There's your hints, I'm hinting to you. What is your expected gain? What is your loss? Remember, if your gain is going to be $18, but it costs them $12 to make, your gain isn't $18. Your gain is what's the difference between 18 subtract 12. That's a big hint there too. Carpet cleaning company, that's a big one. I'm going to leave that number 4 for you to figure out because I want you to try one on your own. Number 4 takes a little bit of looking for the pieces you need. When you find the pieces you need on the probability topic 3 lesson 3 practice questions, things will flow. This is probably one of your toughest part of this unit for expected value. Things get easier after it. And then pretty much we're almost done the unit.